This video demonstrates the solution of example 4 by EPANET using the graphical user interface, running it remotely on the FREESWMM website. The problem statement is contained in the Jupyter book that's online, and I'm going to simply follow the procedure that's listed here. The image converted to a bitmap has already been completed. Here's what it will look like. Same thing as in the problem statement. Start EPANET, so in this case we would have to connect to the FREESWMM site. So there's the connection sequence. Press connect, enter the password, which is FREESWMM, and the files are already there, so we can take advantage of that. It says start EPANET, so to start EPANET, as you'll recall, we go to Applications, Wine, Program, EPANET 2.2, click on the doodle, click on the icon, and we will, looks like it has a new project by default, so let's follow the protocol. Okay, start EPANET, set the defaults. So in this case, the defaults are going to be liters per second. I think we'll know in a second. Let me cheat. It's going to be liters per second. I don't think it has a cubic meters per second as a choice. Let's take a look. Nope. Liters per second it shall be. And head loss formula, we're going to want to use Darcy-Weisbach. Press the okie dokie button, and we're set to go. Then it says to load the backdrop. We're going to go into example 4. There's the backdrop. So we've imported the background. We've done step 4. Select reservoir tool, put the two reservoirs on the map. So the reservoir tool is right here to the right of the hamburger, to the left of the tank reservoir. There's our two reservoirs. Select the node tool, put 4 nodes on the map. 1, 2, 3, ABC, 4. Trying to adhere to the structure. Select the link tool, connect the reservoirs to their nearest nodes. I've intentionally done them angled like that so they don't exactly follow the underlying drawing, but if that offenses you, we can simply do this. And everything's lined up. Connect the nodes to each other. So let's do that. We'll go A to B, B to C, C to D, and I'm going to go A to D. It may not be the correct direction in terms of positive or negative end results, but that'd be good enough. Set the total head in each reservoir. So we'll go here to this reservoir, and the total head is 75 meters. This reservoir is 70 meters. We need the elevations of all the nodes. I'll show you a neat feature. we'll use the group hug. So I selected the polygon drawing tool. To complete the polygon, I'm right-clicking, and then we go to Group Edit, and we will set the elevations to 50 meters to be consistent with the problem statement. Okay, so all the easy stuff is done. Next thing says set the pipe length, roughness, height, and diameter in each pipe. So we'll do the lengths and diameters first, and we'll go back and get the roughness heights. So the length of that pipe is 700. Length of that pipe is 800. That pipe, 1200. That pipe, 1000. This is 250 millimeters. 300. 350. 400. And we want to get the roughness height 0.26. Okay, that should take care of all the pipe settings. Now let's take care of these pipes. It says make the pipes that connect the reservoirs short and large diameter. So short, 10 meters, large diameter, 900 millimeters. And what this has the effect is there's no head loss in these short little pipes, and so whatever the reservoir head is will be the head at that adjoining node. In this case, node A, the head should be really close to 75 meters. At node C, the head will be really close to 70 meters. This is a hydraulic modeling trick more so than it is anything else. And lastly, we have to put the demands in for node B. So it has a base demand of 0.2 cubic meters per second, which would be 200 liters per second. And it's going into the network, so it's minus 200. And this one has a demand of 200. And for reasons not apparent to me, the elevations are at 59 and not 50. So we will go and fix that real quick. It was probably me entered it incorrectly. Check it. All right, I believe everything is ready to go. Let's see if we forgot anything. Save the input file. So File, Save As. We'll call it EX4. I'll put JB for Jupyter Book Example. And that way the EX4.net is the correct one from prior use. Run that. It says the run was successful. Let's see what the output should look like. We should get something similar to this picture here. So let's go ahead and try to activate that. So we go to the map, nodes. I think those want to be head. in links, flow, and view options. I think it's notation. We want to display the node values, the link values. Let's go ahead and turn our flow arrows on. Press the okie dokie button. And with extremely minor exception, we have identical results. So we have indeed solved the same problem. Go ahead and save it. And lastly, if we want to save the input file, we would choose Export Network. Call that one EX4-JB.INP. And now we've left behind our input file, and the only thing we would have to do to use the toolkit usefully, either do direct changes or we would manually change the report block here, and we'll save that for another time. So close the window, exit the program. I guess I'll leave those files behind because there's no harm in doing that. Close that window, disconnect, and we are done.